So if I were to take the center term, which is 3 to the x, and square it, I'd end up with 3 to the 2x, and so essentially this becomes an equation in quadratic form. So I'm going to let b for blob be equal to 3 to the x, and then square both sides. This is 3 to the 2x. So in this problem, wherever I have a 3 to the 2x, I'm going to put blob squared. Wherever I have 3 to the x, I'm going to put blob. And now I've got a quadratic that I can either factor or use the quadratic formula on. And this guy factors into b plus 2, b minus 1. So that b is minus 2, b is 1. I'm not interested in b, I'm interested in x. So this says that 3 to the x is minus 2, because that's what b is. 3 to the x is 1. Is 3 to the x ever negative? No. I mean, this is an exponential, and if you remember 3 to the x, this is what 3 to the x looks like. So it's never a negative number. Never. So 3 to the x, never negative. So this guy goes. Now here, 3 to the x equals 1. Well, I can rewrite this as log base 3 of 1 equals x. And what's log base 3 of 1? It's a property of logarithms.
1? No, 0.
0, yeah. So that x is 0. Now, my domain on this problem is all real numbers because I'm dealing with the exponential function, and I'm looking at exponents here that are 2x and x. That doesn't put a restriction on anything. And 3 to the 2x, it's an exponential. That doesn't put a restriction on anything. In fact, it's 3 to the x with a horizontal shrink factor of a half. And a good old 3 to the x, he doesn't have any restriction on him. His domain's all real numbers. So the domain on this problem, it would be all real numbers. Substitution.